Recall the cost function is represented by the capital CX. The average cost is represented by C bar X. The marginal average cost represented by C bar prime X, which is the rate of change of the average cost per unit change in production. And this is an approximation of the change in the average cost when one more item is produced. For this example, suppose Cx equals 0.02x squared plus 100x plus 2000 represents the cost in dollars of producing x radios. Part A, find the average cost function. Part B, find the average cost of producing 1,000 radios. Part C, find the marginal average cost if 1,000 radios are produced. In part A, we are going to find the average cost function, which is C bar of X. C bar of X can be computed by the Cx, which is the total cost, divided by the X item produced. In our case, C bar X equals the Cx, which is 0.02 x squared plus 100x plus 2000, all divided by X. And simplify each term, we'll get 0.02 x squared over 2, which is x, plus 100 x over x, that becomes 100. And the last term is 2000 divided by x. In part B, find the average cost of producing 1,000 radios. That means we are going to find C bar at 1,000. So C bar at 1,000 equals 0.02 multiplied by 1,000 plus 100 plus 2,000 divided by 1,000, which gives us 20 plus 100 plus 2, or $122 as the average cost of producing 1,000 radios. The last part, we are going to find the marginal average cost if 1,000 radios are produced. The marginal average cost is the C bar prime at X. Our C bar in part A is 0.02x plus 100 plus 2,000 divided by X. So we are going to rewrite the last term as 2,000 times x to the negative first in order to use the power rule. So C bar prime of x is the derivative of C bar, which is the terms in part A, or the derivative of 0.02x gives us 0.02, the derivative of 100, which is 0, the derivative of the last term, which is the constant 2,000, multiplied by the derivative of x to the negative first, which is -1 times x to the -1 minus 1, and simplify to be 0.02 minus 2,000 times x to the negative second, which is the same as the C bar from 0.02 minus 2,000 divided by x squared. And next, we are going to find the marginal average cost of 1,000 radios if 1,000 radios are produced. The C bar prime at 1,000 equals 0.02 minus 2,000 divided by 1,000 squared. And that will give us 0.02 minus 0.002, or $0.018. That means the average cost per radio is increasing because its positive value here is increasing at a rate of 1.8 cents per radio when 1,000 radios are produced. Marginal propensity. The marginal propensity to save, or MPS, is the percentage of the new income that is not spent and instead used for saving. The marginal propensity to consume, or MPC, is the percentage of the new income spent on the consumption rather than save. So the MPC plus MPS, in this case, we use S prime to represent the MPS, or the marginal propensity to save, and the C prime as the marginal propensity to consume. The sum of C prime X and S prime X equals 1. That means the portion to save and the portion to spend as a percent equals 100%. So C prime X equals 1 minus S prime X, which means the marginal propensity to consume is 1 minus the marginal propensity to save, which is S prime X. In this case, C prime X equals 1 minus 0.02X.